So we're going to be solving applications of trigonometry. In order to do that, sometimes in a word problem, you may see the phrase angle of elevation or angle of depression. So let's define those phrases first, and then we'll get into some examples. An angle that opens upward is called an angle of elevation. To elevate means to go up. So hopefully that makes sense. Oftentimes an angle of elevation is on the ground level, although it doesn't always have to be, just often. Sometimes when you're feeling a little depressed, you might describe yourself as feeling down, and so an angle of depression matches that definition, depression meaning down. So an angle of depression is going to open in a downward fashion. So oftentimes angle of depression are seen from things in the sky or things at a given height. So if you're looking down at something either from a building or from an airplane, not always, but typically that's what's going on there. As it turns out, these angles are pretty much the same angle if you just orientate your triangle differently. So if you're familiar with parallel lines intersected by a third line or cut by a transversal there, we have those alternate interior angles. So what you can see here is that if we make a triangle and describe this as our angle of elevation, we could then rotate that triangle around, and now we see an angle of depression. So depending on how you orientate your triangle, an angle of depression can be an angle of elevation. And we'll see that in one of these examples. All right, in this first example, we're given the length of an escalator and the angle of elevation, angle of incline, and we're asked to find the height of the escalator, the vertical height here. So let's label our diagram, and let's see if we can see a right triangle inside here. This would be the hypotenuse in our right triangle. This would be the angle of elevation, and we're asked to solve for this vertical length here, which is going to be opposite from this angle given to us. So using an opposite and a hypotenuse, opposite side and a hypotenuse, we're going to use the sine equation. Sine is the trig function that goes with opposite and hypotenuse. So we'll substitute our angle and the hypotenuse that we know, and we're going to solve for that opposite side. In order to do that, we could multiply both sides by 50 to undo that division. So our height is going to be whatever 50 times the sine of 45 is. And our calculator in degree mode would tell us that it was 35.4-ish feet. So that's how high the escalator rises. You may have been thinking or recognizing this right triangle as a special right triangle. Since we have a 45-degree angle, that makes this other acute angle over here, its complement, 45 degrees. So this is a 45, 45, 90 special right triangle. It's an isosceles right triangle. And in those special right triangles, if I take the leg length and I multiply it by the square root of 2, it gives me the hypotenuse length. So what we could do is we could set up a formula that says, well, the leg times the square root of 2 is equal to 50, the hypotenuse. And in solving that equation, we could divide both sides by the square root of 2. We could then rationalize if we want to keep it in radical form. On the bottom, if I square the square root of 2, I'm left with just 2. But on top, I'm left with 50 times the square root of 2. However, that fraction in front can be reduced. 50 divided by 2 is 25. So in radical form, this value is 25 times the square root of 2. If you find the decimal value of that, it should be equal to this. So two different ways to do that. In our second example here, we're asked to get a cat down from a tree. We grab an 18-foot ladder and we lean it against the tree at a 75-degree angle of elevation. And And the question is, how far away from the tree should we place the base of our ladder? So we could sketch out this in a little simple diagram here. We know the length of the ladder, and as we lean it, that's going to turn into the hypotenuse of our right triangle. 75-degree angle of elevation is going to be down here, opening upward, 75 degrees. And we're asked to find this horizontal length. So given the adjacent side to that angle and the hypotenuse, we're going to use a cosine equation to help us solve for that length. So we substitute 75 for our angle there, and our hypotenuse length, we're going to solve for the adjacent length here. So again, undoing our division, multiplying by 18, our side length is going to be whatever 18 times the cosine of 75 is, and we use our calculator to evaluate it, and it tells us it's about 4.7 feet. So if we take our ladder and place it about 4.5, maybe a little bit more than 4.5 feet away from the base of the tree, we can lean our ladder at a safe angle of elevation equal to about 75 degrees. All right, one more. This time, we're piloting some aircraft and we're flying above the ocean at 30,000 feet. So we know that a vertical length, if we make a right triangle out of this problem, is going to be 30,000. And approximately 6 miles from the shore, we have to make an emergency landing. So 6 miles away from the shore would be our horizontal length. And the question is asking, what angle of depression should we point our plane so that we can make it to the shore? So we could draw an upside down triangle because we know we're going to be finding that angle of depression opening downward there. Our vertical height being 30,000 feet and our horizontal length being 6 miles. Well, before we can solve it, we need to make sure that we have the same units for our dimensions here. So you could convert 30,000 feet to miles, or you could convert 6 miles to feet. Either way, you got to make sure that both of your measurements are either both in feet or both in miles. So we can do a conversion here. There is 5,280 feet in every mile, or 1 mile to 5,280 feet, as I set it up here. We'll set that equal to an equivalent ratio and be able to solve this proportion. So since I set miles on top, I want to keep that corresponding. I'll put 6 miles on top and solve for the amount of feet in 6 miles on the bottom there. We cross multiply. Just turns into a multiplication problem. 6 times 5,280. And we get 31,680 feet is 6 miles. You could do something similar here and convert 30,000 feet to miles. You would just substitute here 30,000 feet so that our feet are corresponding, and then you would be solving for the amount of miles there. When you do that, you get about 5.68 miles. All right, so let's establish what sides we know here relative to our angle. We have the opposite side and we have the adjacent side. So we're going to be using tangent, and since we're solving for the angle measure, we're going to use the inverse tangent equation. Another way that you could do this is you could reorientate your triangle. We know that this is our vertical length and this is our horizontal length, so the angle of depression here is going to be our angle of elevation down here. So if you like to draw your triangles right side up rather than upside down, that's fine, as long as you know where to put your angles that you use for reference there. All right, so I could set up my inverse tangent equation including units that are in feet, or I could change this to be units in miles. Either way, I should be getting something real similar there. Your calculator does the work for you and tells you it's about 43 degrees. So when flying our airplane straight, if we dip the nose down about 43 degrees, we should be able to make it 6 miles and hopefully safely land on the shore. All right, so there's some examples using trigonometry and solving some word problems. You got some practice worksheet problems that you can do on your own. Good luck practicing.